Okay, so origin of genetic variation. This is a test question, so I just want to make sure I talk about it. We're going to talk about this more on your next unit. But there's 3 different ways, and this is a lot in your lab as well. 3 different ways we can get genetic variation: independent assortment, crossing over, and random fertilization. So let's just chat about those in a little more detail. Independent assortment. That's saying that is the random and independent way in which all of the homologous chromosomes line up at metaphase 1. So, okay, just a minute. So here they are. Here are the chromosomes. And I'm going to show you this in the manipulative exercise, but they could line up where you could have, let's say, red is mom. All of mom's chromosomes are on one side. All of dad's are on one side. And they could split so that you have something like this going on, right? Or mom, it could be like mom's to the right and dad lined up this way. It's random and it's independent, okay? There's no law governing which chromosomes line up on which side and which chromosomes end up in which cells. It's just you have one copy of every homologous chromosome. Harper Lee, could you please not talk so loud? All right. So again, it's random and independent. So this occurs at metaphase 1. Okay, it's because there's a test question that says, when does independent assortment occur? I mean, you could say metaphase 1, you could say anaphase 1, but basically it's the answer is metaphase 1, and it's the first meiosis, because that's when the homologous are separating. And how they line up matters. And you've got however many chromosomes, you've got that many different combinations. Crossing over is also a source of genetic combination. That's the mama gets a little bit of papa and papa gets a little bit of mama. All right, that makes it where no sister chromatids are identical suddenly. See, if you look here, at one point, these sister chromatids were identical and the blue were identical. Now we got a little bit of crossing over. Now they're no longer identical because now this sister chromatid's got a little bit of mama and this sister chromatid's got a little bit of papa. So the crossing over also allows for a different combination, and we call that recombinant chromosomes. Once we've had crossover occur, it's called recombinant chromosomes. So again, we talk about that a ton in the lab. And then you have the idea of the random fertilization, that you've got so many different sperm combinations and so many different egg combinations. So when you add that together, you have 64 trillion diploid combinations. If you only just in one, like that's kind of, I don't even know what that is because I'm kind of not paying attention. So, all right, I guess I better end. Here's your test question. Which of the following is not a true difference between mitosis and meiosis? Here's a gimme. Look at this. Again, remember, mitosis, you are going to have identical. Meiosis, the daughter cells are going to be different. This is asking what's not true. During cytokinesis, meiosis, 4 haploid daughter cells are produced. During cytokinesis with mitosis, 2 daughter cells are produced. That all looks good. During metaphase 1 of meiosis, homologous chromosomes are separated. During metaphase 1, or during metaphase of mitosis, sister chromatids are separated. What is wrong with C? Metaphase is not when things are separated. Metaphase is when they line up. So that's one of those ones where it gets people for some reason. All right, this stuff isn't on the test, so I'm gonna let you go. Goodbye, everyone.